When you twist the throttle and feel a motorcycle surge forward, you are experiencing the output of a highly efficient mechanical process. But how does a machine take a few tiny drops of liquid gasoline and convert them into the physical energy needed to push hundreds of pounds down the road? To understand that, we can look at something familiar. This diagram shows a cyclist pedaling a bike. Your leg pushes down in a straight line, and that downward push spins the pedal in a circle, turning vertical energy into forward motion. A motorcycle engine uses that exact same mechanical trick. It replaces the human leg with a solid metal cylinder called a piston, and it replaces the bicycle pedal with a rotating bar called a crankshaft. Instead of using muscle to push that metal leg down, the engine creates tiny, timed gasoline explosions right above it. The force of the explosion stomps down on the piston, which spins the crankshaft. There is a catch. A rider can easily put their foot on a pedal and push. An engine cannot physically trigger that very first explosion from a complete standstill. Think about riding a heavy bicycle. When you are stopped, you need to give yourself a solid push to get some momentum going before you can balance and start pedaling. A resting motorcycle engine needs that same kind of push. You deliver it the moment you press the electric start button on your handlebars. This diagram shows what happens next. A small battery-powered motor engages with the gears of the engine. It physically forces the heavy crankshaft to spin, which pushes the metal piston up and down. As the engine is forced to spin, a magnet on the rotating shaft passes a coil of wire. This sends a surge of electricity up into a component called the spark plug, sitting at the top of the engine. By forcing the mechanical parts to move and generating that first electric spark, you provide the machine the momentum it needs to start pedaling itself. Once the starter motor disengages, the engine enters a rapid, self-repeating sequence known as the four-stroke cycle. Here is a cross-section showing how that works. In the first step, the metal piston drops downward. This creates a vacuum that pulls a mist of air and gasoline right into the open chamber. In the second step, a metal door snaps shut, sealing the chamber. The piston pushes back up, packing that air and fuel mixture into a very tight space. This compression step is crucial. By packing the molecules so closely together, the fuel becomes highly pressurized, allowing it to release more force when ignited. In the third step, the spark plug fires into that pressurized gas. The fuel ignites, creating an explosion that violently drives the piston downward. This is the heavy stomp on the pedal. This exact moment is where the engine actually creates its power. Finally, in the fourth step, a second door opens. As the piston rises one last time, it forces the burnt smoke out of the tailpipe to clear the chamber for the next cycle. With the chamber empty, the cycle resets. This process of pulling in fuel, compressing it, and igniting it repeats thousands of times every minute. Because the explosion is the only step that actually forces the piston down, 3/4 of the engine's effort is spent doing nothing but resetting the pedal so it can stomp down again. When we pull back from those internal movements, we can see how this rhythm drives the whole machine forward. A press of your thumb wakes up the starter motor, a spinning magnet creates a spark, and the four-stroke cycle begins its relentless pedaling. The spinning crankshaft then sends its energy into the transmission, which adjusts the twisting force based on your speed. This schematic highlights the final step. Power flows out of the transmission, travels down the chain or belt, and physically turns the rear wheel. The engine is a precise chain reaction, taking the energy stored in a drop of fuel and turning it into the physical momentum of a motorcycle at speed.